Hey, strangers. It's time for another 2 p.m. PST Twitch stream. I'm your host, Stranger Jim, and today we are going to be getting into some actual coding. Uh, Sorry, I'm running a little late today. Um, had a had a brief moment in my mind going, oh, why bother with this? And it's like, well, no, Jim, you gotta stop thinking like that. Um, for those of you that don't know, um, I keep on. Uh, I have individuals in my life that say stop looking in computer science and go for something else, and it's frustrating because I know I can do the job. I mean, I've proven it before, but I can't seem to get past the interview process or even getting a interview in the first place. So um, it it can be it can be a little tough um, on the morale. So, but we are going to be continuing on our um, work for the game GGG. I can't stop. I won't let the I won't let these people drag me down. Okay, I'm just gonna keep on moving forward on it and uh, struggling against this system, I guess. Um, so, as you can read from the title, we're going to continue our work on pathfinding. Uh, the work that I did and the work that I've done so far in the past has kind of led me down to the point where D star is probably going to be my best choice out of the bunch. Now, uh, for those of you that program regularly with Unity, you might be wondering, well, Jim, why aren't you using the set pathfinding um, given by Unity? Well, couple reasons for that. Uh, first, first reason, with A star, it is indeed one of the best, um, possibilities for pathfinding. Okay, one of the best. I'm not saying that it is the best. I'm saying it's one of the best. Okay, and Unity 3D uses that for its AIs. Um, but here's the thing: with the constant changing of the map of the environment on my game, I need I needed something that is a little bit more powerful than A star. Um, I needed to have um, I needed something that could um, uh, that can basically work in real time. Okay. If the map changes, which it will, whether it's clearing out a resource node or putting down a barrier that blocks the path, there will always be a um, there won't there's going to be some uh, there's going to be a little bit of an environmental change that will require my AI units, which all of them are going to be AI units, um, to move around and change where they're going. And A star, while it's good in that you're going to be trying to find the best path each and every single time, um, it's not always going to be um, it won't be able to handle um, the changing environment unless I do uh, an update each and every single time an agent goes to a new tile. So basically, I'd be running the A star routine every um, for every single agent, every single time that they go to a tile that they need to move to onto the next tile. So, I mean, I look at the very last map and you're looking at potentially hundreds of agents on the map, potentially. Um, because you're going to have not only the human spawning, but you have three other monsters spawning at the same time as well. So you're talking about four agents being spawned like what every 10 seconds or something like that. Okay, give or take. Like I said, and like I mentioned in previous videos, um, that is um, something um, that would require some amount of balancing. Okay, and uh, we're not there yet. So we're not at that level of balance. So um, so we're gonna be kind of trying to tackle um, we're gonna be trying to tackle the D star on this, and we're going to be trying to implement that into Unity. So, hey there, Gabe. How you doing there, bud? Okay, so let's see. I'm just getting some things set up here real quick. One second while I take care of all this. Need to make sure that my headset doesn't shut off on me in mid-speech. Get some music going there. Let's see. It's been a while since I coded anything, so a lot of my um, a lot of my text documents that I like to have is kind of set aside right at the moment, and it's not exactly um, I'm trying to kind of deal with getting everything set back up again. So 1 second. Um, okay, get that going. Gonna have to lower the volume pretty soon there. Doing so good, playing some BF5. Nice. Hmm. I'm missing one document that I like to kind of use. I might have to access it through another means. All right. Let's go ahead and bring that up. Okay, I can turn down that. All right. Okay. There. Looks like we are pretty much all set up here. So let's go ahead and get this live finally. Okay. Um, I'm transferring some files over, so um, things are a little slow right at the moment. So um, so yeah, D-Star. So the purpose of D-Star is to um, one of the reasons for D-Star is the fact that it changes its pathing if it encounters a um, an obstacle in the way. Okay, so it might have an initial path, um, but if it encounters some kind of obstacle, then it will change that path um, to kind of try to go around the obstacle or try to find some other way around it. Um, Now, if there is absolutely no path whatsoever, which, I mean, unless you put up some barriers that blocks the path, there should always be a path for the agents to take. Then it will just keep on trying to find a new route to get around that. So, um, nice background. Oh, thank you. Um, I enjoy that anime. Um, I have it rotating on a through various pictures, so it's so at least on this one, it's not. If anyone knows this particular anime, you know how risque it can get. So I'm not gonna jeopardize the Twitch TOS for that one. But this one was a funny part. I loved it. So um, this particular character was just absolutely hilarious in the anime. Uh, so yeah. Back to the start. So once it encounters um, it initially does the A star to get to a particular destination, and it will follow that path until either it reaches its destination or um, it um, or it encounters a something that gets in its way. You know, some kind of obstacle that stops it from moving anywhere. Now, in this particular case, it could be either uh, an enemy, it could be a monster, or it could be a barrier. There really can't be anything else that really gets in the way. So, um, so um, once it gets to that point, then if it encounters that obstacle, then it will reevaluate its path. It will try to find another path. Now, if it encounters a monster, then I'm going to be trying to have um, the agent kind of running away from it. Um, Again, that there might be a balancing issue on that one because um, first, um, the first round, the first level, if I have the humans running away from the monsters all the time, then um, I mean, what happens when the monsters just completely surround the human city? If they don't have the hunters to take care of them, then it will get to a point where the human city is overrun um, and the player loses. Hopefully, it doesn't get to that. Hopefully, I can balance it to the point where um, it doesn't get to that point. But um, we'll see. Um, we'll figure out the balancing of that when we get there. But in the meantime, we're gonna need to get uh, the pathfinding to work first, so that the the ghouls, ghosts, and goblins can actually get to the human city, and the humans can actually get to the resources, and the hunters can go out and hunt, um, hunt down the monsters and all that. So, um, let's see. There's definitely quite a few um, PDFs that are out there concerning D-Star. Um, Now, um, a couple of weeks ago, it's been that long since I've done it, and since I worked on GGG, so I'm a little it's uh, last couple of weeks have been tough. um, the um, I was trying to figure out what the best method is, whether it's D star or um, the LPA. And um, the lifelong planning A star um, is a little well. There's nothing in their um, process here that stores the route. And um, so I forget exactly what I was kind of thinking about back then. Um, I have a rough gist of it, but I'm trying to remember all the exact little details that I was kind of um, fighting against right at the moment. Um, so LPA has a process of um, kind of modifying the queue and the like. Um, and it tries to store the information for for that one particular path. The problem with that though is the fact that um, it's like a temporary store. Okay, it creates a new queue each and every single time. And um, while that um, it might be good in that it stores the information, but the uh, the if it just kind of dumps that information out afterwards, then it's not really going to be helpful for the other agents. In other words, I would have to redo this over and over and over again for the every single agent that's out there. So, um, so we're basically doing, um, in a sense, we're doing something similar to a D star in here, but it's trying to store the information. The um, there's similarities between LPA and D star if you're not already aware. Um, so you know, uh, unfortunately, I haven't posted the videos on my last couple of coding sessions, so you can't really see the process that I was kind of going through on this, unfortunately. Um, so the um, So here's what I'm trying to tackle right at this moment in time. Um, the um, what I'm want to do is reduce down the amount of checks in the A star. Okay, here let me try to show you what A star is all about. If you're not familiar, okay. Um, Once the website comes up. So with A star, it basically checks, you know, from where you're at all the way out. Okay. Um, so, take this example right here. Okay. You're starting from a particular node and you're kind of expanding out from there, trying to find a path that gets closer and closer to, um, to your end goal. Okay, so you're starting there and you're just continuing to expand out. Okay, and when you're factoring that being done by every single agent that's out there, um, and I'm looking at it from a point of view that um, you have basically four agents being spawned in, you know, every like 10 seconds or so, then um, you could have a map that's full of these agents that are trying to find the correct path that they want to take every single time. Okay. And if if the path gets blocked, they still might be trying to go to that one particular node, but they can't because it can't get there. Okay. So like for example, if this wall extends all the way, down, for example, then this path will never reach the destination. Okay, but if this path was determined before this wall was realized, before this wall was seen, then it will just kind of continuously running into the wall, trying to get through that barrier. Okay, um, that might work when it comes to the monsters because the the barriers that humans set up can be broken. Um, but um, the um, were um, this could be potentially a problem. This could be a problem for the agents to try to overcome. They might have some difficulty trying to figure out, that hey, um, we can't, um, we can't get past this barrier, so we're just gonna keep on running into the barrier over and over and over again. Okay, so um, and it's funny when you see artificial intelligence is just kind of like maybe going back and forth, along a wall trying to figure out some way of getting past it, but they're not really understanding the fact that they have to kind of go around. Um, so um, Now, when you start increasing the amount of people that's out there that are trying to do this A star path each and every single time, okay, and same goes with the D star, okay. Um, D star is basically a similar style to A star. Um, it just changes its course based off of if there's something that gets in the way. Um, so if say this path right here suddenly gets a wall, then it will go, okay, I reached this point, I have to kind of go around that way, for example. Okay. Um, the having this, you know, work, trying to have this happen for all the agents that are potentially going to be out there on the map, it gets a little concerning. Okay. Um, so that's why I was initially thinking of looking at the lifeline planning because I was thinking maybe this is storing the path um, for all the agents to access to get to um, to get to the destination that they want to get to. So if there's like a common destination and there's already an agent that has already figured out that particular path, then I figured this lifelong planning would go about doing that. It would kind of store the information for the next agent to access, and it wouldn't need to go through the process of searching through all the nodes to get to its destination. It can just use the path that um, that was originally created for that particular node. But there isn't anything like that, um, or at least based off of what I was reading and exploring. There really isn't that much in terms of um, storage of the path um, outside of the agents. So, and that kind of goes with the D star as well. D star doesn't have any kind of storage of the path either. So I think what I was trying to figure out, or what I was trying to, um, I was kind of kicking around last time, was could I store the path for all the nodes so that the agents, once it gets to a particular node, it can basically say, oh, I need to go to this particular route because that's the path I need to go. So I'd be doing a D star A star pathing if the routes change, if the landscape changed, but I would still be um, kind of storing the information so that the next agent going on that particular node wouldn't have to redo that path. And there isn't really anything in in here that kind of does it. I mean, lifelong is similar to what I kind of need, but not quite. So, um, so what I think I'm gonna need to do is um, maybe try to expand upon like the D star and the lifelong planning A star to try to store the path from one node to the next in the within the node itself, but that that increases um, the runtime storage of the game. Um, Now, how much of a danger is that? Um, I'm first game here, so I'm not quite sure how dangerous this could be. So, on one hand, you can have um, 20 plus agents all at the same time trying to do um, D star and A star, almost every single round, almost every single time that they reach a particular node, and it could increase over time. Okay, I'm giving 20, but I mean, um, again, that's a balancing issue that I haven't gotten to yet, and um, we'll get there when we get to a working, functioning game. To once we get to like an alpha state, um, then we'll be able to check to see whether or not we can, um, whether or not we need to somehow increase or decrease the amount of agents that are out there. Okay, but having them doing an A star search every single time for all of them all at the same time, that's going to put a lot of strain on the mobile phones and the PCs on which that's the initial thought line that I had for this game. Get it out on mobile, get it out on PC, and um, you know maybe not so much the PCs, but probably the mobiles are gonna really have a hard time on it. Maybe just speculating here. Um, or I could have the initial pathings being done, but because they're being stored, I'm not going to be running the A stars or D stars as much. So the runtime demand for the path, um, the looping process of trying to check every single node, it won't be as high because once a path is determined, that path route can be stored. So once another agent goes to that particular node and um, wants to get to the same destination, then it just has to access that route and follow it. It doesn't need to do an A star or D star again. So it can kind of follow the same path. Um, so while the the looping of the path might, or the looping process of an A star or D star might not happen as much on this particular scenario, the amount of storage that might be required for keeping those paths might increase or will increase over time. So um, which what would be uh, might be more of a challenge? Would the storage itself of each of the paths be a problem, or would the looping of through the entire map be a problem? I don't know. Um, okay, I'm gonna need to update at some pretty soon. It's been a while. Skip that for now. Okay. If I if I store the paths, then that means that um, all the nodes will require a um, reference to all the other nodes that are on the map. Uh, that could be. I mean, that's not too much of a problem when you're talking about the smaller maps that I have, but as I've mentioned previously, um, as the levels increase, so do the maps in size. Um, so let me see. Don't think I'm showing it that much here. Um, yeah. So the idea is, once you get into the higher levels where all the monsters are present, then obviously the player is going to need a little bit more room to kind of get the resources that they need in order to beat the particular level. Um, so hence my mentality of increasing the size of the map as you go along. Okay, going at a smaller size map in the very beginning levels, you know, so it's not that difficult to explore or gather resources or along those lines. But again, this could potentially be a balancing issue. Could potentially cause some issues um, as you kind of progress through. So that's the reason why I gotta be careful with that. Okay, are we going to load up the code or no? Let's see. Have some old errors. Like I mentioned before, it's been a while since I've uh, since I touched the code. Been dealing with a lot mentally. Um, but um, it's just taking a while. Okay. Oh, um, one of the reasons, another reason why I don't necessarily want to use the um, Unity's A star. Um, the reasoning behind um, that I'm a little worried about Unity Say Star is because I'm setting it up to be a tile-based board, and I don't know whether or not Unity Say Star can work with the with my tile-based system that I have. I don't know if it handles that or not. Okay. Um, I'm under the impression, which I could be wrong. Again, I haven't really messed with Unity Say Star, but um, seeing that it is a, you know, um, their main goal of the game, their main idea of the IDE is 3D. Um, the concept of um, set locations, set tiles. I have I have the assumption, which again could be wrong. I will admit I could be wrong. Um, that um, that their A star might basically ignore those tiles. Okay, they might go by the system of um, just trying to go around um, the map in its own, using its own pathing to kind of move around. Okay, um, so it might work in a 3D environment in a 3D map where you don't have any like set tiles or anything along those lines. Um, but um, that might not necessarily um, that might not be the case. Okay, that it might actually work. Again, I don't know. Um, I haven't really worked enough with Unity's 3D system to determine whether or not it can actually work in like a tile set. You know, like if I was to make a 3D version of say the game Clue, okay, um, would the A star work with the nodes that I'm forcing upon it, or would it just kind of go, oh, you need to go there? It's like, no, you know, it's like instead of kind of bouncing along um, the square spaces to get to its destination, you know, uh, would it, try to like zigzag through everything to get to that particular spot? I don't really, I don't. Again, I haven't used Unity as much, so um, you know, this is pretty much my um, first attempt um, outside of the tutorials for Unity um, to really kind of create this game, GGG. So, um, okay, so now that we have our code base up, um, okay, so I was manipulating Hextile CS. What was I doing there? Let's see, line 122. Hmm. Okay, let's see. Now, if I remember correctly, right. Okay, so, hmm, I think I was moving a lot of my code around because it was originally within board, but I think what I was doing was I was moving a lot of the assets around. Yeah, yeah, I moved these particular classes outside of board manager because I was messing up there. Um, uh, so what we're going to be doing is working on getting um, okay, so I was looking in the idea of for each tile creating a map to the to a particular node. Um, hmm, okay. Uh, so that's the route that I was thinking about doing. So um, okay, we'll have to continue with that then. So let's see. Now, eventually, we're gonna need to get um, the pathing going for all of our agents and the um, you know, initially, you know, it was just kind of like, here, let's kind of mess with our movement a little bit, you know, having it kind of move around a little. But obviously, we need to. This is not gonna work. This is not gonna be um, something that we can. Um, uh, obviously, this won't work for the game. Um, because that would mean that I would have to program each and every single agent to do, you know, the uh, a set path each and every single time, and uh, that might work um, in some platformers, you know, where you have uh, the enemy kind of on a set path going like back and forth and so on and so forth, but not for this game. um, so Um, so let's see. We have hex path, which will take the information um, from the A star and store it within our hash table, um, and basically give it a value that we can kind of create um, for the destination. So um, right, so returns null if the key isn't found. So basically, once it gets, we're so here within the agent, um, we're going to be, um, let's see, where where do I want to put this at? Where's the best place for it? Um, okay. This is all initialization. Um, okay, we're going to be going through each of the humans here. I really do need to remove all the um, comments that I've put on here. So, toggle move. 52 destination. So we're doing the testing path here. Um, but what we should be doing is um, check to see whether or not we can actually get um, get the path. If it hasn't been created yet, then um, we're gonna need to um, we're gonna have to kind of work our way through the process of that. Uh, we have, this is our, um, this is gonna basically store our, um, what we want to add into the list. And I'm doing it as a linked list so that they can go, um, each node down the way on it. So, um, so I can just kind of create like a little temporary list to, as a copy of it. And as each node of the list is done, then I can just kind of remove it and until they kind of reach their destination. So, um, So, let's see. Um, add tile, next tile key, and then we do have to take, add, let's see, next tile. And we don't necessarily need to do any kind of return back on that. So um, let's see. Let's see, public, next tile key, get next tile. Let's see. Then we do have to take. Let's see. I don't know the code for that, unfortunately. I don't have the C# completely memorized yet, so let's see. Okay. I'll go ahead and save that for now. Okay. So as we are while uh, in the agent and its pathing, which is what we're going to be doing the D-star in, we're going to need to be storing, um, once we find the path that we want to take to our destination, then we're going to need to kind of store that path inside the hex path for that particular tile. Um, so, um, once we have that particular path, then we basically put that path inside the tile's map pathing for that particular destination. Okay, or at least uh, that's the idea. Have the have a hash value for the destination, um, and then um, store the path in our hash table so that we can retrieve that destination again using the hash value, and then um, pulling the path out from the map pathing. So that's what this is. That's what this is all about. So um, now um, hmm, remove first. Hmm, Does that actually show? And do you actually get the node out of that or no? Probably not. It looks like it's just a complete remove. So let's look at the methods here. Um, adds a specified new node after the specified existing node. I don't need to worry about that. Um, oh, add last. That's what I'm probably going to be needing. Okay. So it's not just add, it's add last. Okay. So we should be fine on that. So the idea is that the first node that it finds will be, first destination. Then we're going to add the next tile over as, add it to the end of the linked list. Okay. And as it continues down the path, it will just add, another node to the end of the linked list. So when you get to that, you know, um, when we get to the path to take, it will, look at the very first node of the linked list and traverse um, down the linked list properly. So that's the idea of it. We'll see if I can get it to work. So um, now instead of get, we're gonna need to okay, so we have remove first and remove last. Okay, so that's just clearing out that particular node. So um, so that's fine, but we need to access the next node in the list here. I have a funny feeling that it was up above um, in the examples. I think it was referencing next. Yeah, let me move back up there again. Um, yeah, so here's that. Okay, so what is current? Okay, what is current? I'm not seeing any values of it. There it is. Okay. So it's basically saying linked list node. which is a string, being created as a current, looking at the sentence find last of the string, or it's basically saying uh, find the last string within the linked list that has the word the in sentence. So um, okay, so the display here is basically showing the linked list values is equal to the fox jumps over the dog. So um, that should be true. So we're gonna have today being added to the beginning of the list. So today the fox jumps over the dog. Um, and it will display the sentence after this particular test. So mark 1 is taking in the first node, which is today. We're removing the first node, and we're adding today into the very end of the list here. So the fox jumps over the dog today. Um, Now we remove that last node, get rid of today, and it adds in yesterday at the very end. So the fox jumps over the dog yesterday. Again, it removes it stores the last, so it stores yesterday. It removes it. It adds yesterday at the very beginning. So it should be yesterday the fox jumps over the dog. And then it removes yesterday. And then it checks our list here to find the last person, the last the. So it skips this one and it finds that one. So it stores current to be that. So um, so that's where it's indicating. Um, so so it adds old after the, then it adds lazy after the again. Um, so for those of you that might be kind of wondering what the heck is going on here, um, so what's happening is you have the fox jumps over the dog, right? Well, um, here, let me tab this out a little bit so I can properly um, indicate that this is current. This is the current spot for current. You know, for the. So what's happening here in this particular example is that it's adding in old after the, and then it goes right back to current because current hasn't changed. Current is still pointing to the, and it adds in lazy. So, uh, so that's your sentence right at this point in time. So then it says, you know, find Fox. So now current is no longer on the, it's on Fox. And gets that particular node. So far, I haven't gotten to the point of it traversing through the linked list yet. So that's why I'm a little hesitant um, on jumping into this too quickly here. uh, so now it says add before current, quick and brown. Um, so before current we have quick, and then um, I'm gonna lurk. No problem there, Gabe. Catch you later. Okay. Um, and then we're going to add in brown before current. So there we go. So that's how our sentence is looking at like it now. Okay, we haven't removed old and lazy from up here. You know, we moved current, so we're still having the same kind of sentence at this point. Okay, so now we've taken care of this. It displays everything. So now we're having Mark 1, which is um, you know, uh, it was pointing to the first of our entire sentence here. So it was here. Um, or it was there before. Or no, wait. It was at the first. Then we moved it to the last. So it would be there. And then here we're basically saying, okay, we want Mark 1 to be at the same location as current. So then we have Mark 2 being put at current's previous. So current's previous is brown, so we want Mark 2 there. Then we move current to find dog. So current is now there. There we go. Which is fine there. Um, let's see. Add before method throws an invalid operation exception if you try to add a node that already belongs to the list. Interesting. So if you're seeing that Mark 1 is already kind of pointing to a particular node. What I was trying to do was it was trying to basically like um, copy this particular node to right before dog there, but you know, basically it's saying, hey, you can't do that. Now, you might be able to, yeah, I would imagine. Again, I'm not sure. I haven't messed with linked lists on C# before, so this is um, I'm I'm speculating here. I should still be able to add fox before dog if I did the add before. If I did, you know, add before current fox, then it should be able to create like a new node here, you know, perfectly fine without any kind of issues to that. Okay. It's just saying, hey, I can't take a node that you're pointing at already and copy that. Okay. You can't use already established nodes. You would have to create like a brand new node for the most part, prior to dog. So dog needs to take a chill pill, all hyper. Yeah. I mean, you know, uh, your animals can get that way. They want some playtime. So yeah, I mean, unless you get yourself like some fish or something like that, that's not going to like interact with you directly, then you're probably going to be experiencing that, no matter what animal you get, pretty much, you know, maybe, like I said, depending on the animal. Okay. Um, even cats, even cats can be like that. So even though, uh, you know, majority of the time, cats still like to kind of, be all lazy and all that to kind of, just kind of lie down. Hey there, John. How you doing? Welcome to the stream. No A star? Um, well, D star is a variant of A star, so um, the idea for D star is to allow for changes to the map, to allow for the changing of the path depending on whether or not there is a um, in the change in the map. And seeing that my map is going to be changing pretty much almost constantly, almost, depending on what the player does. Um, A star isn't going to be uh, as useful. So I'm going to be looking to D star to kind of take up the slack on that. So okay, let's see. Now, okay, when linked list is cast to an I collection, the add method adds a node to the end of the list. Okay. What would be the purpose of doing that though? I mean, this is pretty much the same as doing add last. So, you know, so unless you're going to be using the iCollection as um, in something, um, unless you're going to be using the uh, iCollection somewhere else, which doesn't really doesn't really make much sense in terms of if you already have sentence, why are you creating an iCollection? So kind of curious about that. Why would they go about doing that? Um, you have a for each, which I mean, couldn't they just use the iCollection for that as well? They could have probably done iCol here instead of the S array, or they probably could have used sentence here. Maybe I don't know. I don't know how for each handles linked lists. So um, so we'll kind of see how that works for the most part. Okay. Today, yesterday, or today, yesterday, jumps over um, the dog, jumps over lazy old dog, indicates the fox node, quick brown fox, indicates the dog node. Um, fox is already on the list, so that doesn't happen. Um, move the reference node fox before the current node dog. Okay. Right. See, this is where uh, they removed the node and moved it before the current on that. Um, you know, if they wanted to keep Fox in the list, they probably could have done the add before and just had Fox there if they really wanted to. So, um, tried to find her again. Um, they added dog into the list there. Um, remove a node that has the value old. Remove last node. Cast it to iCollection and add the rhinoceros. Copy the list to array. Their linked list contains jump equals false. So now you had previous being referenced, and I wonder if it's gonna be previous is gonna point to the one prior, the node prior. You have sentence pointing to first, or the first pointing to the very beginning of the node, um, or towards the beginning of the linked list. Um, but there's nothing concerning next on this. Here, let me first and last, okay, and count, but it's not referencing previous or next. Let me do a search for this real quick. No previous, no previous. There it is. No next. So the fact that they don't list that here is kind of troublesome. I mean, unless it's under a different, maybe it's under a linked list node. Um, yeah, it's under linked list node. Okay. So, hmm. So with that in mind, huh? Let's see. So what we want to do, our linked list system here, is we're going to, um, reference the first node, and then we're going to um, basically return the value back. So we do this. So first, and then can we actually access the contents of the node by using value? Not sure. Let me look at our properties of first here. Okay, so it is a linked list node. So um, I can pull the value from it by using this right here. So um, okay, what we're gonna want to do is we're gonna need to kind of a create a copy so we don't necessarily destroy the um, um, the original path. Um, so what I'm gonna do here, um, uh, uh, first tile is equal to all this. Then what we're gonna do is we're going to remove. Let's see, I think it's capital remove first. Oh, okay, hold on. Um, Go back. Um, we have remove last, but yeah, we have a remove first. So, and then we return first tile. Okay, um, so we're going to be kind of storing, um, so for this particular um, process, we're going to be basically adding, uh, for our hex path here, we're going to be constructing the path and then storing it in this particular hex tile. Okay. Um, so um, and then um, obviously we don't necessarily need to remove the paths from the hex tile. Um, well, we might need to um, change the path. Hmm. It would require you to kind of take the original value and kind of replace it. Hmm. Okay. So let's see. I'm gonna give myself some drink here. Come on. Okay. So, but I don't know if there's really anything else that I really need to do here. Um, because um, this will be used to construct the path, which we then store in the hex tile. And then we just have this one that basically um, destructs the path as you go along. So, um, so if the agent has the um, has a path that they want to follow, has a path that they need to take, it will use this to get the next path that they need to go through, um, get the uh, get where they need to go to next, and it will then remove the first because it no longer needs to go to that node anymore. Okay, if I don't do this, then it's just kind of basically be in an infinite loop of trying to get to the first node each and every single time when it's already standing on that tile. Okay, um, so I need to remove the first from the path there afterwards, so it no longer references it. Okay, it just removes it completely. So like if so for example, if I have some values like 8, 10, 12, and 14 in a path, just as a reference here, um, we're going to get 8 from that first, return it, remove it, so that um, so the next time get next tile gets called, we just have a list of these values. So once again, we get the first value, turn it into first tile, which will be returned, and then it gets removed, and it repeats ad nauseum till the entire path is done and they've reached their destination. So rinse and repeat. So so yeah, I don't think there's really anything else that needs to be uh, done here. Um, I might want to uh, as a testing, I may want to display path. Um, so for each let's see, hex tile key value that to take. So value dot x or what am I looking at here? No, I need logs. Debug log. That's what I'm looking for. So actually, hold on. I just want one line for that. What is the best way of kind of seeing the node here? Yeah, I don't think it's going to be able to. I don't think it's going to be able to automatically give me the hex tile keys as a value yet. I think what I need to do is get the linked list node of the hex tile key value, and um, let's see, is there a way for me to see the position of the node? Doesn't look like it. Okay. Next position, or next path value, X. Y. Value, value, Y. Okay. I think that is fine for us to kind of work with there. I think. Could be wrong. Okay, hex tile key. Oh, it's row and column, not X and Y. Hmm. Okay. Okay. Okay, so I'm doing this in the let's see. Here, let me change the name here just so it doesn't get like confused somehow. There we go. So I'm doing this as like a precursor. So when I start actually creating these paths, um, once I get the D star going, and I want to I want to see whether or not um, the pathing is set correctly, then um, then we'll I want to kind of see um, what the what the path is going to take based off of after it gets created. So that's the main purpose of this. Um, you know, uh, for testing purposes, remove for production. Okay. So, um, so I don't necessarily need this when I get done with the full-on testing process. Um, so I can just kind of get rid of it. It's not needed. So, um, Okay, so now that we have that, um, we have our generating the hash key. So seem to be okay on this for the most part. All right, so what I want to do is check out um, all of our errors here because I know that I'm dealing with quite a few. Hmm. I appear to have messed up here. Is it in? Let me make sure. I thought it was as. No, it's in. Okay. Messed up there. Okay, here's all the other issues that we're dealing with here. Um, Hash table could not be found. Hmm. Okay. Interesting. I'm also kind of curious why it's having a trouble with vector 3 as well. Hmm. Oh, it might be the fact that I don't um, have this on there on our classes. Possibly. Because a lot, our classes tend to have like, the mono behavior and like because of, Unity. So because I don't actually have those on there, it's probably having some issues with that. Um, hmm. Do we add mono behavior on these for now? Could be wrong on that, but we'll see. I might need to change that mono behavior to something else. Get the structure correctly. So, okay. While it's trying to handle that, just for me to kind of see the next set of errors that I'm probably going to need to kind of tackle, we can move on. So for the most part, we are kind of ready to go, I would imagine. So, um, hmm. I gotta be careful with this because I don't necessarily want it to send back the original path. I want it to kind of send back a copy. So let's do it this way. Copy of path equals that. The reason why I'm doing it this way is because um, when I get to this point of, you know, traversing the path, I don't want to potentially have the removing of the first there to completely destroy the hex tiles path of it. I want it to kind of store it for the, um, you know, for the next agent that comes along and wants that particular path. Okay. Now, I could be completely wrong on it, but I got to be careful with the references here. Okay, I don't want to be referencing the um, um, you know, I don't want it to be referencing a um, you know, I got to make sure that I'm not referencing the actual path there, which um, which makes me think that I should probably um, this might be wrong as well here. So what I probably want to do is do new XPath. So we are creating a new object here, having it, um, you know, uh, save the value of the path to it, and then we return that. We return that reference. So maybe we'll see. Okay, that didn't really work as well as I wanted it to. Okay, so it's probably because I'm not using um, any inserts. So um, save those. Okay, so that should reset that. Yeah. Okay, so linked list, we need a reference to that. So now what I probably want to do, grab this, and then we don't need all the generic references, so we just need to reference both the linked list and the linked list node in this particular case. Now, um, it's for the board manager, it's still going to be referencing everything kind of contained within it anyway. I'm just doing this one because, the linked lists and the linked list nodes are, specific. So, um, um, now we should be fine for the most part. We just need to, you know, take care of the hash table here. Okay. So it requires a type. Interesting. Okay. So hex tile key. What am I missing here? What's going on here? What is its error about? Oh. Hmm. Could I be making it a little too specific? Maybe I need to just kind of reference it as just T. And that'll work. Nope, that wasn't correct either. Hmm. Let's take a look at our example over here and find out what's going on here. Oh, they just use generic and that's it. Hmm. The problem with, the generic is the fact that it has um, a lot of library references here, and I'm just wanted to kind of um, lower the amount of references that's it's doing. So so it doesn't fill in that entire library, at the very beginning. Okay, you can do that. Okay, um, so when you are um, creating the um, okay, when you're looking at the code here, okay, this is for anyone that is like interested in the code. Okay, I could I could say, just using system. Okay, I could just do that. and be done with it all, right? Okay. Problem with that is the fact that, you know, this right here fills in um, to kind of understand what's kind of I'm gonna talk a little bit about the preprocessor here, preprocessing, um, or at least my knowledge of it. So take it with a little bit of a grain of salt because my information might be slightly inaccurate. Um, but basically, um, when the um, when you're about to like launch the program or when you're starting up the program, okay, the um, you have the what's the word for it? Interpreter, preprocessor. Basically, it scans through the code. Okay, it looks through all your code. Okay, and sees what needs to be added in for it. Okay, now when you're doing these particular, includes using so on and so forth in the code, basically what it does, okay, is that it looks in the library for these particular references, okay, and it goes, oh, okay, you're trying to go to um, you're trying to go to this particular namespace. Okay, well, we're going to add in all of these, all the code for every single last one of this, all these classes into the beginning of your code whenever you do like a reference here. Okay. It adds in those libraries. Okay, so that it's basically like kind of contained, you know, Now, obviously, you as a programmer, you're not actually seeing that. This is kind of all happening, you know, right at like the launch of the program kind of thing when you're like, compiling it to get to the point of execution. Okay. Um, it basically takes the information contained in here and just kind of deposits it like right at the very beginning of it. Okay. Um, so that it could just kind of reference the methods and all all these all these methods, all these structures, interfaces, everything just kind of gets included in it all. Okay. Um, and it's you can limit what information it's referencing, okay, by by specifically saying, hey, I just want, the LinkedIn class. Okay, I just want the LinkedIn. That's it. Okay, that's all I want. Okay. So it doesn't need to um so if you put in like, system collections generic, you know, you're not adding in all of these values in there, especially when you're not using them all. Okay. Currently I'm not using stack or sorted set or sorted list or anything along those lines. Okay. So uh, ideally, it would probably be in my best interest to just have, systems collections generic um, linked list to kind of limit down the amount of library references I'm doing inside the game. Okay. I don't have to worry about the um, all this extra um, information in the library being added to the very beginning of the code each and every single time, you know, or at the very beginning of the compile. Um, so, obviously it if you have more advanced computers and so on and so forth, the processing time for that, isn't nearly as long. But um, you know, uh, seeing that I'm going to be, the idea here is for me to eventually get it to a point of um, um, you know, moving it to mobile, and I'm going to need to try to save as much space as I possibly can. I want to make sure that this game runs as smoothly as it can. Okay, I don't want to have any complaints about this game is super laggy. Okay, um, so I need to make sure that um, I need to build this game in such a fashion where I cut out a lot of the unnecessary, searches or um, data creations or anything along those lines. Okay, I need to make sure that I handle that properly. So, okay, good. I'll go ahead and take care of that real quick. There we go. Okay. So, I think we are pretty much ready to go for the most part. Um, Now it's just a matter of um, building the path here. Okay, so I'm having the pathing go with the destination there. So what we're gonna want to do is instead of this, which obviously doesn't work, isn't gonna work for the long term. What we're gonna want to do, just comment that out for now. I'm gonna do the destination is going to be equal to the um, okay, wait. First off, let's see. We're going to need to figure out whether or not um, Wait, hold on. Okay, I'm gonna need two separate functions here. So in the game manager here, we're doing, we were originally just kind of like having we were just kind of testing out the pathing of everything, getting um, getting the value there, and eventually, um, well, this one was actually changing it again, but eventually we were getting to a point where we're attempting to move after that. So, um, a lot of this is pretty much fluff that we need to kind of get rid of here. Um, so, um, so we need to check to see whether or not the path has been created already. If it hasn't been created, then um, we kind of create um, the path. Now, can vector 2's be null? I'm not 100% sure on that. So, vector 2 null. Okay. Okay. Right. Vector 2 and vector 3 are not able to be null values. So, um, yeah. Hmm. Let's try this. Okay. So how am I gonna go about doing this here? So here's where my mentality is right at the moment. Okay, um, so eventually we're going to be um, I'm gonna go ahead and remove all this. We don't need it. Okay, so what we're gonna do is um, based on our location, um, we're going to um, let's see. We're gonna want to get the agent's position so that we can um, change it over to the um, to get the hex tile that we're standing on. Then we get the generate a hash key here. So yeah, let me kind of move all this in here. So um, then see. Um, but here's so okay, we generate the hash key with the with the wrong column. Okay, um, that was the intention um, for this. We generate the hash key, we get back a value, um, and that will be our integer for the map pathing here. Okay, so then um, we get the we try to get the path. So um, we have integer hash value, and then we um, the hex tile um, get path with the hash value key. Will return us um, the hex path here. So we want hex path um, path to follow, which actually um, what we want to do is we're going to need to change our destination into something that is so absurd that we're never going to see it. So, um, so our agent needs to have the path. So private XPath path to follow. I just go ahead and null that. So um, so our path to follow will take in whatever gets returned to us from get path. Now, um, get path could return null if the key isn't found. Okay, if our generate hash key um, comes up with something that doesn't work for our map pathing, then we know that there isn't an actual path created for that particular node. Okay, for where the agent is standing on. So, um, now that if so, um, if path to follow is null, or actually isn't null, then what we want to do is um, what we're going to do, we're going to get the next tile to move. So path to follow, get next tile. Um, Now we're sending back a hex tile key, so we need to save that. So hex tile key, um, next node, and then we want destination x is equal to next node row and destination y for the next node column. Okay. Right. So um, if these haven't changed at all, then we know that um, you know you know our attempt to a new destination isn't correct. So um, let's see. Two. I'm just gonna fill it in with dummy values there. So if the testing path here um, doesn't generate a change in our destination values, then we'll know that we're going to need to go into pathing here. So, um, so if destination dot x is equal to negative 9,999, which is not a value on my map, um, then we can move on to actual pathing here. So um, and obviously um, eventually it will determine um, the first portion of the path. Okay, so what's going to happen at this point? Okay, so we have the testing path here. Okay, we're checking to see whether or not um, it has a path. Um, we're generating a key based off of row and column, um, which we're getting the row and column from the position of the agent. So um, I need to make sure that I'm not screwing up here. Hold on a second. Um, hmm, let's see. Hmm, I gotta be careful here because the transform positions doesn't always translate um, to the cell locations, to the tile locations. So hmm, oh, wait a minute. I keep on changing the agent location. Hmm. Agent location is based off of our tile locations for the most part. So okay, so if that's the case, then I'm gonna use that. Or down here. Okay, so we have the generate hash key for the x and y value. We get it from, um, and then um, let's see, we need to get this specific, um, actually, I don't necessarily need the agent's coordinates because I just need the tiles coordinates to kind of get that. Wait, hold on. Oh, wait, hold on, no. Um, okay, so here's, uh, I'm off here. I'm off. Um, so the destination could be different. Um, our destination might change. It might, um, we might want uh, a, our AI agent to kind of go towards a resource or um, to the human city or something along those lines. So um, let's see. Hmm. So um, so our destination could be coming um, from where our agent wants to go. So we haven't gotten to that point yet. We haven't gotten to the point where our agent is figuring out where it wants to go just yet. So um, what I'm probably going to want to do is um, let's see, public void um, um, determine destination 8 vector 2 destination. And right now, just kind of copy this for now and just kind of use that, I guess, for now as our, where our AI kind of wants to go for the time being. We can modify this a little bit later to try to figure out. Um, we can change its idea on where it wants to go, through this particular um, function for our AI agents, and we'll use that here. Um, hmm. Let's see. Okay, I gotta be careful here. I gotta be careful because I don't want to screw up the destination path here. So, okay. I think what I'm gonna need to do is actually have a boolean here. So let's do a boolean. So, um, boolean, let's see, is path established. Set it to false. So, um, path established, set that to true, and then we return is path established. So, um, so just for any kind of what you're kind of looking at here. Um, so um, instead of agent location, which is incorrect, we're looking at our destination coordinates here. You know, where we kind of want to, you know, our destination, we're trying to generate a hash key there so we can figure out whether or not that there is an actual path to our destination. So, um, so we get our path, and if the path is null, meaning that there hasn't been any established path already generated, then we're going to need to go into our D star to generate the optimal path to our destination. Okay. Otherwise, if it did find the path, um, then um, then we get our um, then our path to follow is already set. Um, let's see. I probably should do. Now, path to follow is something that I want to try to keep within each of the agents so that if um, when when we want to get to the next tile, we can just easily get to the next tile. Um, so um, so um, so what I should do. Okay. Here we're gonna do something a little interesting here. Um, so path follow. Okay, so if um, So here's what we're trying to do here. Um, so the um, what we're doing right now is um, trying to figure out um, where we want to kind of go to our next node, okay, in our path here, right? So um, so what we're doing is we're getting our destination coordinates, okay, and we're checking to see if our path is already established, okay. If our path is already established, then we don't need to worry about finding the path. Okay, we don't have to worry about that. Okay, because we're just kind of follow what's kind of already been established. Okay. Um, Now, if there's like a block or if there's been like a change to the map or something along those lines, obviously the path to follow needs to adapt to it. It needs to change. Okay. Um, so, um, so if the path has already been established, if they're trying to follow the same exact path, then we don't necessarily need to find the path. Okay, we don't need to see whether or not the node um, has a path already established for that particular route. Okay. Um, so um, so what we're gonna do, okay, um, so we now determined that, you know, hey, this particular agent already has a path to follow. Okay, we know that it's not equal to null. So we're gonna go inside here. We're gonna get the next tile within the path. Uh, determine, get the x and y values for it, and we're going to say, hey, the path has been established. Um, we don't need to worry about, um, path finding. Okay, so we come back here to the game manager, um, and let's see, we're going to need another boolean here. Um, let's see, is there path? I set that to false initially. And actually, we don't necessarily need to worry about setting it to a value. It's gonna get a value no matter what from this. So is there a path? It's gonna be equal to that. Okay. So now we can take that and put it here. Now, um, if there is a path, then we don't need to establish a new path to it. We don't need to establish a destination. Okay. So what we can do is say, if there's no path, if this is false, no path has been established yet. Okay. Then it needs to come into the pathing to determine where it needs to go. Okay, where, you know, determine all the nodes, all of the locations for it, and so on and so forth to get to its initial destination. And um, we don't really need these. Um, um, so the attempt move might work and might not work. Um, if the attempt move runs into something, then we're going to have to change the path or or re-update the path. Now, um, if uh, if the attempt move um, fails in some fashion or another, then we're going to need to uh, redo the pathing, from our current location. Um, so um, if um, otherwise, it's just going to traverse the way it needs to traverse. So um, we don't really need the destination there. We need it to look at our determined destination. So HVAL determined destination. Um, I want it to um, hmm, actually, hold on. Um, I want to change its destination a couple times. So, hmm, kind of wish I still had those nodes from before. Oh well. So, let's see. Okay. Gotta be careful here. Gotta be careful. Um, okay, so um, sorry, I want to make sure that my ideas are going to be good here because I don't want to screw up anything here. I don't want to screw up the order process. So um, so we determined that the worker is not working and whether or not the worker is scared. If either one of those are a thing, then obviously we need to kind of do something else. Okay. Um, Now uh, we want to toggle its move, which changes the animation. Um, and we set up a boolean for is there a path. Now um, we know that it needs to go, and we know that the agent needs to go somewhere. We need to have it traverse, go to a particular, destination. Okay, so that's what this is all about. Okay, we determine the destination of um, um, of where we kind of want to go. So um, destination s is equal to 9, then we can do that. Um, else if destination x is equal to 8, then I know that I want to go to a different destination. So I can do something like um, let's do something like 3 and 4, just for the hell of it. Um, and then we'll do like, one last node or something like that. We'll do something along the lines of let's see, let's do like 4 and 9 or something like that, maybe. I don't know. We'll see if that works. Might not work. Um, my maps might be a little too much for that, possibly. We'll see. Um, Obviously, there's more. This is gonna have to change. We're gonna need to, um, you know, this will require player um, interaction either by banner or resource default. So um, Oh, but I gotta be careful here because um, this might be different based off of the whether or not it's, we're looking at agent right at this moment in time, but there's different agents. It could be human, could be ghosts, could be ghouls, could be goblins. So I gotta be careful with that because um, um, destination for a human, whether it's the worker or the hunter, could be different than the ghosts. So um, um, so this might be changed based off of the type of agent, you know, whether or not it's human or not. So I gotta kind of be careful with this a little bit. Um, but for now, this will have to kind of do. Um, uh, this also depends on on whether a agent is human or monster. Okay. But either way, we have ourselves, three potential destinations to go to. Um, I'm just kind of doing this way just for kind of ease of use here. Um, so that determines our destination, which technically what we want to do is do at destination again there, and new vector 2, set its values initially. Uh, so it can figure out that, hey, you need a destination to get to. Um, so then it comes out with its where it kind of needs to go, and um, then we go into testing path with our destination. Now this this might be a little problematic here because um, if our um, we gotta make sure that we're not already on a path. First off, so um, okay, so let me kind of let me do a step by step here. So human just got created. Okay, they aren't working, nor are they scared, so they need to move somewhere. So toggles move. We set up is there a path for the boolean. We set up initial value for our destination because we don't have a destination as of yet. Okay, so so then we go into determine destination and we get our where we want to go, right? So we go to determine destination and we get first our first location where we need to kind of walk to. 8-4 is our first location that we want to path to, right? Okay. So we send that back out, and that gets saved in our destination, right? So then we go into testing path. Okay. Now we know that we don't actually have any paths established yet for this. Okay, so we're going to go into here with our destination. Um, we we know that our path hasn't been established yet. We know that our path to follow is null. So we're going to be going down here. We're going to test out the X and Y, generate the hash key for the hex tile. So we take the 8 and 4 here, we generate a hash key for it, and we put it into the hash value key. Then we check to see whether or not there's an actual path for the hash value key. Now this is where we know that we don't actually have a path established for it yet. So we come here and we know that the get path will return a null value. So path of value is still null. Okay, so um, um, so if the path is still null, then obviously we can't find the next portion of our destination, right? Okay, so we come here, path, path, this path established is still false, so we come back here, okay, um, our destination hasn't changed, so um, our values here haven't changed. They are still the same values. Just bear that in mind here, because things are gonna get a little funky a bit. Okay, so um, so we come here. This is false because we haven't found a path. So we actually do the pathing. Okay, this will allow us for doing the D star and so on and so forth to get our um, to get where we need to go. Okay, and eventually we need to make an attempted move as to where we're going. Okay, the next tile that we need to go to. Gotta be careful with this though. Okay, because um, so we do a path here. A we establish a path to follow here within pathing. Okay, and we get our destination from it. Okay, now um, now what we're probably going to want to do is we're probably going to want to do um, probably going to want to do something like testing path with dest again. Okay, um, so in here we're building our path to follow. Okay, that's being established here. Okay. Um, so um, we're adding our tile to our list here. So um, let's see. Okay, so we're finding the next. Uh, we're gonna kind of establish our path, our D star path here, and we're gonna basically add these tiles into our path here. Okay, for our hex tile here, um, which um, we gotta be careful here because we're we're gonna need to do the hex tile that we're currently on, add path, and have to follow. And we need the hash key for it, um, so we need to have this up here as well for our destination. Here, let me actually. There we go. So this happens after all this. Um, so we're gonna um, basically we're kind of be doing a loop here, um, where we're gonna be adding in the tiles into our path here. Um, you know, the star loop for determining path. Um, uh, path build. So determine hash key for storage. Add path into hex tiles path list. And then determine next tile to move to. Okay, so um, I'm just kind of do like the whole D star for the most part up here. Okay. Um, then we're going to generate the hash key based off of the destination that we're going to be going to. So in this particular case, it's going to be 84 for our initial. Okay. Then we add the path into the tile in question here. Okay. Um, then we go to testing path. Now the reason why I'm doing the testing path here is that I want to kind of reuse the code in here for the most part. Um, so we know that the we know that we're establishing a path already. Okay, so we don't necessarily need this boolean here. Um, but I do want to try to keep this pretty much um, I want it to be, I want this to kind of be kind of separated out. Hmm. Maybe I should do that in its own function then. Because I don't necessarily need to do all of this all over again here. So, um, so here, let's go ahead and public, or actually let me do private because we don't need this outside. Um, void, um, get paths next tile, um, out, vector 2, destination. We'll use the full word this time. Um, we'll take that, move that there, clean up the format there a little bit more. Um, so dust. Okay. So now we can just kind of copy that and move that there. Because I don't need to go through all of this again. We've already established a path to follow. So we just need to get the next tile from it, or get the first tile that we want to move to, and all that. So okay. Let's see. Um, okay. Hmm. Okay, so now that that's all well and done here, we're kind of already, um, we're getting the destination of 8 and 4 and all of its nodes associated with that based off of our establishing of the D star up here. Uh, we're going to be, um, we're going to get our value there, which we'll do an attempted move on it. Okay. Um, but the thing is that our destination value changes. Okay. The tile that we want to go to might change, might be a little bit different. Than it might be like, 7 and 2, for example. Okay, so we don't really know. Okay, it um, might be a little different than what we're needing to kind of deal with. Okay, um, than our initial destination. Okay, we determine our destination there, and it changes here, or by this point, our destination has changed at the very least. If not, it's already changed here. Okay, our destination changes from where we kind of want to go versus um, where we kind of need to go to get to our initial destination. Okay, so this is where things get a little complicated here because let's say our our destination path for 8 and 4 covers like multiple different nodes. Okay, let's say it covers like 4 different nodes. Our destination changes to the next node by this point. Okay, so instead of 8-4, it changes into something like 3-3, then 3-4, then 4-4, then 5-4, then 6-4, then 7-4, then 8-4, for example. Okay, our destination keeps on changing its values here. Okay, so this determined destination um, might be it might continuously try to determine its the destination that it kind of needs to go to, but um, that's the thing. It might be um, it might already be established. Okay, so if I go back to this point here, okay, then my values here have changed for the A value in this particular case. Okay, um, my value here has changed. It's no longer 8 and 4. It's like 3 and 3. Okay, which means once it gets back to this point, well, um, the our path is no longer uh, is no longer the same. Um, it's no longer 8. Okay, so my values here is gonna not really work out that well. It's gonna go straight to the 4-9 afterwards because I'm changing the values here. So how how do I figure this part out here? Because um, so just for example, okay, I've determined my path for the first node for 8 and 4, right? It goes to the um, it goes to the first node in the path. Attempts to move to 3 and 3. Okay, and then it loops back around. Okay, comes right back here. It's not working. It's not scared. Um, so um, we determine, is there a path? Okay. Um, we set our destination. We basically destroy our 8 and 4 values on that. Okay. But we already have a path going. So, so when we get here, um, we shouldn't necessarily need to worry about determining whether or not we have anything. No, we shouldn't necessarily need to worry about, you know, do we need to go to a new node? So what I should do is if path to follow is null, then do this. Meaning if our path has been um, if our path has run out of tiles, meaning it has been kind of deleted completely, and we no longer have the next destination, then um, uh, we can um, we can kind of figure that, and figure this if our path has been um, already established, we don't necessarily need to worry about this further out. Okay. Again, this will be modified later depending on um, the human or monster decisions or so on and so forth. Okay. But I still want to have that path to follow. Okay. Because if it's already on a path to get to a particular location, then I shouldn't necessarily need to worry about checking its decision process on whether or not it needs to change its destination. Now, um, now I might want to add some additional checks here, maybe, or there might need to be more checks in, say, in the human or the ghouls, ghosts, and goblins, um, as to like uh, maybe the human player needs to set up like a red alert flag, like I I absolutely need this particular resource. Everybody that has the that isn't going for this particular resource, you need to change your path to that particular resource or something along those lines. Okay. Um, so I might need to have um, like a check there for whether or not the player like sets up um, like a banner or something along those lines. Now, again, this right here might need to go into more the human ghouls, ghosts, or goblins. I'll worry about that a little bit later. Okay. Um, but for now, we'll just kind of leave it here for the time being. Uh, we're not at that. We're not at that stage of, um, you know, hunting for resources or anything along those lines. We're just trying to get the pathing to work for our map for the time being. So, um, but if the path has already been established, then we don't need to worry about, you know, getting our next destination set. If it hasn't been established, then we set it, so on and so forth. Um, so we get our destination, we go to a testing path, which could potentially change our destination. So that's where I'm wondering about this. Maybe I need to change this into um, something a little bit different. Maybe I need to do something along the lines of destination and um, next tile node or something along those lines. Let me do something like this. Do out here. And we change that there, change that there, change that there. So, in other words, we're changing our we're keeping our destination set. Um, hmm, but we don't have any initial values for vector. What are the default values for vector 2? I should probably look that up. Uh, default value. Hmm. And default 0 every time. I'm not sure. That's the reason why I'm asking on that. If it's 0, then that could be problematic because if any one of my particular nodes is if any one of my particular nodes is set to 0, 0, then how am I going to determine whether or not if I establish um, a vector 2 for the first time and I need to set its vector, how will it know whether or not the node in question um, is the vector default values or if it's the tile x and y values. And welcome to the stream there, Mathis. Thanks for stopping on by. Appreciate it. I'm unfortunately going to need to close down here pretty soon, but I want to try to figure this part out a little bit or I screw myself over. So, okay, let me um, so the what I want to kind of be careful about is, I know that, 9,999 negative is not going to be anywhere on my particular map. So hence the reason why I'm setting them like so. Or at least initially. I don't know if this is the correct method of doing it again. I'll look it up later. Um, but if I change them here, then this kind of becomes a problem because I won't be able to do it will constantly be setting destination to 8 here because it will keep on looping back through here and resetting the destination to 9,999. I would love to be able to say if um, if I can do something like, um, you know, obviously I can't do this because vector 2 can't be a null, but, if I had something like that, then I'd be able to, establish the value initially um, and that's all well and good. But when I do this anyway, the value's not gonna really store. Hmm. I'm just kind of setting up this for testing purposes. I know that I'm not going to keep this, but I just want to try to have um, I want to be able to kind of move the agent around the map appropriately, mm, but I can't do this. This isn't a thing. I can't. It's a structure, so. Hmm. Actually, let me do it this way. I know that this isn't going to be something to keep, so we'll just go ahead and take that and move that here. Um, so just for the hell of it. Okay. Um, just doing any kind of like, initial testing or whatnot. So I'll just kind of changing our values here. Um, okay. So I mean, we're not changing anything there, so we don't need to worry about that. At least I don't think I need to worry about it. Um, let's see. See, I'm always kind of worried about the default values. I'm resetting it each and every single time, so. Hmm. if I have a tile set that's set to 0 and 0 for its location, then I'm going to be in trouble. Especially if I do something like, um, if destination is equal to 0, and destination y equal to 0, then set up our initial. Um, but again, this gets reset back to 0, 0, doesn't it? So it may never see these other values here. Um, hmm. Okay. There. Path could be set to true at the very least. So there's that. Hmm. We'll have to see whether or not, destination changes. Um, I might just kind of put this up here for the time being. Put that up there so that we can determine what the value is each and every single time that we are changing our um, changing what we're doing here. Now, if this continues to go, 0, 0 each and every single time, then, that's a problem. Um, but um, then it will never get out of the 8.4 in that particular case. Um, I would have to set like, specific booleans up each and every single time to kind of get through that. So, okay, um, to kind of path it through properly, not uh, not look at its set values. Hmm. Um, okay. I think that's okay. I might have a loop here going. That's kind of bad, but we'll have to kind of figure that out next time, I think. Um, let's go ahead and make a note here to do um, fix testing path and pathing for nation change. Um, also, um, not sure if 3, 4, or 4, 9 are going to be reached. So work on that. All right. So we're gonna have to kind of pause it here for now. Um, I'm probably gonna just need to kind of use like booleans or something like that. Initialize some fake booleans up here, to for the initialized game, so that we can just kind of um, just use them here in the if else statements so that we can actually reach those particular destinations. So, um, but yeah, we're still not done with all this. We still got plenty of errors that we need to um, deal with here within Unity. So, um, so apologies for not actually getting straight into D-Star on this, but we'll we'll continue working on that um, again next week. So um, just need to just kind of needed to set up everything. So um, should have probably put that in my description title, shouldn't I? But that's where we're gonna go and call it for tonight. Um, so for those of you that are um, curious, I did set up a stream team available for anyone, whether or not you're a streamer or not. Um, everybody's welcome on the team. Uh, the team is all about trying to help out everybody that's on it. Um, so if you're interested in it, or if you're interested in my initial description of it, the link is down below on my Twitch about page. The uh, Within the application itself, there's a Google document that talks about the team, talks about the what I want to see with the team, how I want it to grow, um, what my vision for the team is going to be all about. So check that out. If it's something that you're interested in, submit your application, and then um, if everything works out, if everything checks out perfectly fine, then I'll be sending you an email, whether or not it's uh, you can whether or not I don't have a problem. If there's if I spot some potential problems at all, like maybe attitudes that kind of go against the mission statement, um, then um, I'm sorry, I'm probably gonna have to say no. Um, but um, it's we'll see. You know, um, I would like to think that I have a you know fairly open, tolerant mind, um, so that I'm flexible on it, but don't don't push it. Don't push those boundaries. Um, Otherwise, yeah, won't be able to allow you into the group, into the team. But it's there available for anyone that is interested. So check it out. Hopefully, I'll see you on the application page. Um, but so yeah, that's it for the application. All these streams, all these videos are eventually uploaded to my YouTube channel, so feel free to check that out if you like. Got a link down below for that. I also have links to my Discord, my Patreon, and my Twitter account down below on my Twitch About page, as well as in the description of my YouTube. Sorry about that. Um, Link in the description of my YouTube videos, so feel free to check those out if you like. I have a schedule of everything that I do on this channel, all the games that I play, these coding streams that I do every Sunday, as well as the Finish What I Started series every Mondays. So check that out if you're interested. Um, but yeah, that's where we're gonna go ahead and call it. Um, I do stream daily from 2 to 6 p.m. PST. So stop on by, say hi in the chat if you want, or don't. It's perfectly fine if you just want to lurk. Um, I want to give some shout outs to Gabe, John Hillington, and Mathis for showing up today and talking with me. I appreciate it. And for anyone that's lurking, thank you for stopping on by. I really do appreciate the support that you give. So uh, hopefully you have yourself a good day. Have a good night. Stay healthy. Stay safe. I'll catch you strangers next time.